Quantum physics, also known as quantum mechanics, is a branch of physics that deals with the behavior of matter and energy at the smallest scales, such as atoms and subatomic particles. It provides a framework for understanding the peculiar and counterintuitive nature of the quantum world. One of the fundamental principles of quantum physics is the wave-particle duality. It suggests that particles, such as electrons or photons, can exhibit both wave-like and particle-like characteristics depending on how they are observed or measured. This means that particles can exist in a superposition of states, where they are in multiple states simultaneously, until they are observed or interacted with, at which point their wave-like behavior collapses into a definite state. An example that illustrates this principle is the famous double-slit experiment. Imagine a barrier with two small slits in it, and a screen placed behind the barrier to detect the pattern of light or particles that pass through. If we shine a beam of light or shoot particles, one at a time, at the barrier, we would expect to see two separate bands of light or particle impacts on the screen, aligned with the two. However, in the quantum realm, things behave differently. When particles, such as electrons or photons, are used in the experiment, they can actually exhibit an interference pattern on the screen, as if they were behaving like waves. This means that they can pass through both slits simultaneously and interfere with themselves, creating a pattern of alternating dark and light bands on the screen. This phenomenon demonstrates the wave-particle duality of particles. Before the particles are observed at the screen, they exist in a superposition of states, with a probability distribution that describes the likelihood of finding them at different positions on the screen. It's only when they are observed or interact with the screen that they collapse into a definite position, appearing as individual particles at specific locations. Another key concept in quantum physics is quantum entanglement. This refers to a situation where two or more particles become correlated in such a way that the state of one particle is immediately linked to the state of another, regardless of the distance between them. When two entangled particles are observed, the state of one particle instantaneously collapses to a specific value, and the state of the other particle is simultaneously determined, no matter how far apart they are. Quantum physics has revolutionized our understanding of the microscopic world and has led to various technological applications such as quantum computing and quantum cryptography. It challenges our classical intuitions and continues to be an active field of research, with ongoing efforts to deepen our understanding of its principles and implications.